So here are some examples of polynomial long division. And first of all, let's kind of review the division algorithm. And the division algorithm just says that if we're going to do long division, if this is our divisor, that's the number we're dividing into the dividend, which is the number we're dividing by. Okay? The divisor in the dividend equals the quotient plus the remainder over the divisor. So the dividend divided by the divisor equals the quotient. The quotient is the answer up here. Plus the remainder, whatever remainder we get over the divisor. So that's the division algorithm. And here's a simple little example. Nine divided by 4. 4 would be the divisor. 9 would be the dividend. So 4 into 9 goes 2 times. 2 times 4 is 8. Then I would subtract, and I would have a remainder of 1. So that'd be the remainder over the divisor, 1 over 4. So that's kind of how that works. And polynomial long division is just like long division. We basically do everything the same. So let's try an example here. So first of all, we're going to divide, and we just always check the first term in our divisor compared to the first term in the dividend part that we're dividing. And I want to see how many times x goes into x cubed, or what do I have to multiply x by in order to make it look exactly like this? Well, it looks like I have to multiply by x squared, so I'll put x squared up there. Now let's multiply x by x squared, and we get x cubed, and that's what we want. And then I multiply x squared times negative 3, and I get negative 3x squared. Okay? And these should line up pretty good, because we have all descending powers. And then we subtract. Now, usually when we do long division, we divide, multiply, subtract, and bring down. Divide, multiply, subtract, and bring down. Sometimes we call that daddy, mama, sister, brother. But in order to subtract, we usually just add negatives. So all we do is change the sign. So change each sign, and then add. That's like our subtraction. And these become 0. They always will, because that's how we designed it. And then 3x squared, positive 3x squared minus 1x squared now is just 2x squared. So we've got 2x squared. And then I bring down my positive 10x. And then I just repeat. Okay, so what do I have to multiply x by in order to get exactly 2x squared? 2. So I'll multiply that by, 2x, excuse me. Positive 2x. Now that should check out. So when we multiply 2x times x, we get 2x squared. Should be exactly the same. If I multiply 2x times negative 3, I get negative 6x. And I'm going to subtract, so I'll change the signs, make this negative, and make this positive. That becomes 0, and what's 10x plus 6x? 16x, so I've got 16x. All right, then I bring down the 10. And then what do I have to multiply x by in order to get 16x? To multiply this by 16, okay, so that's going to be, so I'll multiply this by exactly 16. So that's going to be 16x, and 16 times negative 3 is negative 48. And I'll change my signs. That becomes 0, and that becomes 58. So there's my remainder. I'm all done. And I can rewrite the remainder over the divisor. So it's going to be plus, like we said up here, the quotient plus the remainder over the divisor. So 58 over x minus 3. Okay, hope that makes sense. Now we also had something called, we talked about this too, the remainder theorem. And the remainder theorem says if we do get a remainder, when we divide this, then the value of this polynomial, so if I call this polynomial f of x equals x cubed minus x squared plus 10x plus 10, and I want to evaluate f of 3, that would equal 58 if there's a remainder. Whatever the remainder is, that's going to be the value. And that's what we call the remainder theorem. If a polynomial is divided by x minus a, the remainder r is p of a, so, or f of a in this case. So if we put 3 into this function, we could just check that. F of 3, that would equal 3 cubed minus 3 squared plus 10 times 3 plus 10. What would we get? Well, 3 cubed, 3 times 3 is 9 times 3 is 27, minus 9, and 10 times 3 is 30, and plus 10. What's 27 minus 9? 18, plus 30, plus 10. Well, 30 plus 10 is 40, excuse me, 30 plus 10 is 40, plus 10 is 50, plus 8, 58. Excuse me. That equals 58. All right? So you can see that how that remainder theorem works. If we evaluated it, we could do all this, or we could just look at the remainder there. So hopefully that all makes sense.